Welcome to the Destination Earth Core Service Platform. Eagle is a visual workflow builder for Geospatial AI, running on Destination Earth. It's a training environment, built to pull in satellite imagery, pre-process it, train or run AI models on it, and export results, all by connecting nodes on a canvas. On the left, you have the node palette, organized into data sources, pre-processing, inference models, tools, and outputs. On the right is your workflow canvas. At the top, the standard controls: save, open, new, and run. So far we've seen how Eagle handles change detection, an automated, model-driven workflow. But sometimes you don't want a pre-trained model deciding what's interesting. Sometimes you want to point at something on the map and say, "Find me more of these." That's exactly what the SAM3 Interactive Segmentation node is for. SAM3, the Segment Anything model, version 3, is a foundation model that can isolate any object in an image given either a text description or a visual example. It's promptable, it's fast, and it doesn't need to be retrained for every new use case. Let's see it in action. We start fresh with an empty canvas. From the Data Sources palette on the left, we drag a raster input node onto the workspace. We click Browse Server Files, and navigate to the project's input folder. For this demo, we'll work with a much higher resolution scene than Sentinel-2, Riyadh_600.TIFF, an 8.4 megabyte Maxar commercial satellite image of Riyadh, Saudi Arabia. Working at this scale unlocks a different category of analysis. Instead of fields and forests, we're looking at individual rooftops, vehicles, and infrastructure. Eagle Auto detects the metadata. The sensor is correctly identified as Maxar. The CRS is EPSG 32638, UTM Zone 38 North, which covers the Arabian Peninsula. The image is 1964 by 1119 pixels with 4 spectral bands. And here's the important detail: the resolution is 15 centimeters per pixel. At that scale we can see cars, individual trees, swimming pool tiles, even the panels on a rooftop solar array. This level of detail is exactly what SAM3 was built to exploit. Next, we drag the SAM3 Interactive Segmentation node from the inference category and connect it directly to our raster input. No band selector is needed here. SAM3 is a vision foundation model that works on natural color RGB imagery as is. The configuration panel is refreshingly simple. We give the run a name, pool, and choose our compute device. Auto GPU if available, lets Eagle pick the fastest backend. Output formats are flexible. GeoJSON for vector polygons we can open in QGIS or ArcGIS, a GeoTIFF raster mask for further raster analysis, and optionally training tiles if we want to use these segmentations to fine-tune another model later. But the real action happens when we click Open Interactive Map. Eagle launches a full-screen leaflet-based map viewer with our Maxar scene loaded as a tile layer. We can zoom, pan, and inspect the imagery just like we would in any web GIS. This is where SAM3 differs from a classical pipeline. Notice the two modes in the top left panel: text prompt and draw. These are the two ways we can tell SAM3 what to look for. Let's start with text. SAM3's text prompt mode is genuinely remarkable. It accepts plain English descriptions like buildings, roads, or water bodies, and finds matching objects across the entire scene. We type pools into the prompt box. Below, the confidence threshold slider is set to 0.50. This filters detections by how strict we want the model to be. Stricter values keep only the strongest matches. Looser values cast a wider net and include more borderline detections. We click segment. The model runs. SAM3 is performing open vocabulary detection across the full extent of our scene, matching the visual concept of swimming pool against every patch of the image. And there we go, 8 pools detected. Each one is highlighted with a colored polygon, and on the left, you can see every detection listed with its confidence score and area. The top result came in at over 91% confidence, that classic kidney-shaped pool down in the lower left. The next one, around 90%, is a larger rectangular pool. And further down the list, you'll spot a bright blue pool near the bottom of the scene, and even a green-tinted one, probably affected by algae, or maybe just a pool with a colored liner. Both detected with strong confidence. What's really striking here is the diversity. Look at what SAM3 just did. It found pools of different shapes, different sizes, different colors, in completely different surroundings, and we didn't give it a single training example. That's the power of a foundation model. The visual concept of pool is already baked into its weights, ready to use. Now let's tackle a harder problem. Suppose we want to map every rooftop solar installation in this neighborhood. Solar panel is a more ambiguous term than pool, and at 15 centimeters resolution, we can actually trace one ourselves. We switch to draw mode. The map prompts us to click to place first vertex. We use the polygon tool to trace one solar panel array on a rooftop, that distinctive blue-tinted grid pattern. Click around the perimeter, double-click to the first vertex to close. This single polygon is now our visual prompt. Instead of telling SAM3 what to find with words, we're showing it an example. We hit Segment. SAM3 takes our example, extracts its visual features, and scans the entire scene for objects with similar appearance. 12 objects found, and they're all rooftop solar panel arrays. Look at the variety. Large industrial-scale installations on the upper rooftops, smaller residential panels in the courtyard, oriented in different directions, with slightly different colors and aspect ratios. The model generalized from one example to 12 confident detections. This draw once, find many workflow is incredibly powerful for operational mapping. Instead of labeling thousands of objects to train a custom detector, an analyst can label one, and let SAM3 do the rest. When we're satisfied, we click Save in the top right. And every detection can be exported in different formats: GeoJSON polygons that you can drop straight into QGIS or ArcGIS, a binary raster mask if you need it for further raster analysis, and optionally those training tiles, in case you want to use these segmentations to fine-tune your own model down the line. SAM3 Interactive Segmentation flips the traditional remote sensing workflow on its head. No labeled training data, no model retraining, no waiting hours for a fine-tuning run to complete. Just a prompt, text or visual, and a few seconds of inference. Combined with Eagle's no-code interface and high-resolution data support, it turns interactive object mapping from a multi-week project into a 5-minute exploration. Whether you're inventorying urban infrastructure, monitoring informal settlements, mapping solar adoption, or auditing pool installations for tax compliance, SAM3 inside Eagle puts that capability one click away. Thank you for using Eagle.